This is section 234. We're going to go back to solving quadratic equations. So we're going to examine solving a quadratic equation in 3 different ways. So remember, our quadratic equation is in the form of ax squared plus bx plus 3c. It has that square in it. That's how we can identify that it's a quadratic equation. Anytime you see x squared and it's the highest power, we know it's going to be a quadratic equation. And just know that the domain of all quadratic equations are from negative infinity to positive infinity. Now, we've already looked at the zero product principle, but just as a reminder, zero product principle means if a times b equals 0, you can either assume a equals 0 or b equals 0. So we use factoring to be able to do that. And so we want it to equal 0. So I subtracted 3 on both sides. And this is where we do a times c. You get negative 6. What factors of negative 6 give you a negative 1? It'll be the negative 3 and then the 2. So I'm going to break up that minus x into the minus 3x and the 2x. Now I can do factor by grouping. And so there's an x in common on the left side. There's a 1 in common on the other side. Now with this statement here, there's a 2x minus 3 in common. And so factor out the 2x minus 3. And then once it's factored, remember this is your a, this is your b. So you can set each one equal to 0. So 2x minus 3 equals 0. If you solve, you get 3 halves. X plus 1 equals 0. And solve, you get negative 1. Now, you can also solve these with a square roots method. Now, there's no real magic here. It's just the only term that you have is an x squared. There's no other x there. So if you have this type of scenario, it means that you actually want to get the x squared by itself to solve. So I'm going to add 10 to both sides, divide both sides by 2, and then I can square root both sides. And so I'm going to get x equals plus or minus root 5. Now, you're going to see this idea be very common throughout this class. When you're trying to find quote-unquote real solutions, what are the solutions to this equation? Well, what you're actually trying to do is you're trying to find where the two equations intersect. And we're going to examine this actually a little bit further in this chapter. But just know that it's saying, where does this intersect with 0? And so if we go through and we solved it, so I factored it into x plus 3 and x plus 5, set each equal to 0, I get negative 3 and negative 5. Well, notice at negative 3 and at negative 5 is where it intersects with 0. Those are our solutions to the equation. Now, there's a few other names that you're going to see. Solutions could be the same as zeros. It could be the same as x-intercepts. You can even see a phrase called roots. All of those words mean the exact same thing. It's asking, where is it intersecting with the x-axis, or what are my zeros, or what are my x-intercepts? Now, the last is the quadratic equation. We need to know this. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, something that's often forgotten is that x equals. That's actually really important because it says x squared, so I know it's going to be x equals. If this said, to kind of really change things up, well then, because that's an a, this would actually be a equals. If I said, and we're going to look at something like this later in class, 3 sine squared theta plus 2 sine theta equals 7, that means that this would actually be sine theta equals. So whatever the quote-unquote value that's being squared for the quadratic equation, that's what it equals. And so now all you have to do is just make sure you set it up. So you want it to equal 0, because that was the general equation of our quadratic equation, or standard form equation, however you want to frame it. Now we can identify what my a is, what my b is, and what my c is. And so your a is here, your b is here, and your c is here. Now, once you identify those values, all you have to do is plug in and simplify. So plugging in 2 for b, plugging in 3 for a, plugging in -7 for c. The rest is all simplifying. So you want to look at things like the 2 squared, multiplying -4, 3, and -7 together. Now I can add the 4 and the 84 together. Now I can simplify the square root of 88. And so that breaks into square root of 4 and square root of 22. Square root of 4 is 2. So I have 2 root 22. Now, I know you're looking at this and you're probably thinking, oh man, that 2 and the 6 reduce. And this is a concept that hasn't really been emphasized in previous math classes, and you're going to see it emphasized more in this class. But the only thing that reduces are factors. You need a factor in the top and the bottom. Well, what's a factor? Factor is multiplication. This is not multiplication. So I cannot just reduce that 2 and that 6. So if I think of it in terms of factoring, well, what's in common between the -2 and the plus and -2 on top? Well, 2. So what if I factor it out at 2, and then the 6, I think of that as 2 times 3. Now factors reduce, the 2 will cancel out. So it's kind of like you have to reduce it in everything. You can't just do it the 1. It has to be everything. And so you get -1 plus or minus the square root of 22 over 3. So if I wanted to write it as x equals, those are going to be my values, because that plus or minus, I can break it into multiple values. So what did we learn today? We learned how to solve the quadratic equations 3 different ways. And so the zero product principle, just remember, if you have 2 values being multiplied equals 0, you can assume each of those factors equals 0. And then the quadratic formula is -b plus or minus square root of b squared minus 4ac all over 2a. This does conclude our lesson. If you have any other questions, please leave them in the comments.